Welcome to section 12.10. This is the 136th session of the CISSP exam prep series. In this session, we'll unpack how private networks reach the internet without exposing themselves. What problem does network address translation solve? How does one public address serve a whole office? Which private address ranges make it work? And what related addresses should you never confuse with them? Why does this matter beyond the exam? Because translation is what lets thousands of internal machines share a handful of public addresses while staying hidden. Imagine a startup with 200 employees behind a single leased address. Get the translation right and outsiders see one anonymous doorway. Get the addressing wrong and connections silently break. On the job, you will diagnose exactly these situations from nothing but the address a machine reports. What problem does network address translation solve? It hides your internal layout and stretches scarce public addresses. Network address translation, or NAT, swaps the private address of an internal client for the public address on your border device as traffic leaves. Outsiders never learn how your internal network is arranged. It also lets you run any private addressing you like without colliding with real internet hosts. As a bonus, it acts like a simple one-way firewall, since replies are only allowed back in when they answer a request that started inside. Think of it as a receptionist who places all your outbound calls from one company number so nobody outside sees the individual desk lines. How does one public address serve a whole office? Through a close relative called port address translation, also known as overloaded translation. Plain translation maps one private address to one public address, so one lease equals one simultaneous user. Port translation goes further by adding the transport port number to the mix, letting a single public address juggle thousands of conversations at once. It does this by mapping each internal address and port pair to an external one, effectively multiplexing many sessions over one lease. In practice, the word NAT usually already means this port-based version. Picture one phone number with a switchboard routing hundreds of extensions behind it. What happens when translation meets a VPN? There is a wrinkle worth knowing. Traditional translation breaks IPsec VPNs because rewriting the packet headers looks to IPsec like tampering. The fix is a feature called NAT traversal, designed specifically so IPsec and other tunneling protocols can coexist with translation on the same border device. This lets an organization enjoy both hidden addressing and encrypted tunnels through one interface. Think of it as a special envelope that lets the receptionist relabel the outside without disturbing the sealed contents inside. Can outsiders reach in through translation? By default, no. But you can deliberately open a door with static translation, also called port forwarding or reverse proxy. Here you pre-map a public socket so an external party can start a connection to a specific internal system. It works, but it is generally discouraged, because handing outsiders an easy way in erodes the protection translation gave you. It can be reasonable for a system sitting in a screen subnet or extranet, but never for a machine on your trusted internal network. Treat it as cutting a hole in your own wall, justified only when you truly need one. Does translation apply to the newer IP version 2? Yes, through a technique made for IP version 6. Even though the newer protocol has an enormous address space, some organizations still want to conserve public addresses or hide internal detail. This technique maps many private version 6 addresses onto a smaller pool of public ones, so external parties see only the shared public address. It is somewhat debated, since the newer protocol was designed to give every device a unique address and direct end-to-end reach. Still, specific deployments choose it for conservation and privacy, just as they always have with the older protocol. Which private address ranges make this work? A set of blocks reserved long ago for private, unrestricted use. There is one large block starting with 10, a middle set of blocks in the 172 range, and a familiar block starting with 192.168 that you see in homes and offices everywhere. Routers on the public internet refuse to carry these addresses, dropping any packet that claims one as its source. That is exactly why they are safe to reuse internally, and why pairing them with translation slashes the number of public addresses you must lease. What makes translation stateful? It works by remembering the conversations it is handling. When an internal request goes out, the device rewrites the source to its own public address and records that swap, along with where the packet is headed, in a mapping table. When the reply returns, It matches the reply against that table and redirects it to the correct internal client. Because it tracks the state of each active session this way, we call it stateful. Think of it as a coat check that hands you a numbered ticket, so the right coat comes back to the right person. What is automatic private addressing, and why does it signal trouble? It is a fallback that kicks in when a client asks for an address and the assignment server does not answer. The machine gives itself an address from a special self-assigned range with a standard mask, which only lets it talk to other stranded machines on the same segment, never across a router. It is a Windows behavior and is not really a security control. But it is a useful clue. If you spot a device wearing one of these self-assigned addresses, something upstream failed. It might be a dead cable or a downed assignment server, or it could be an attack against that server. What is the loopback address, and why keep it separate in your mind? It is a purely software address that a system uses to talk to itself over the network stack. The whole range beginning with 127 is reserved for this, though in practice one specific address does all the work. It exists so you can test local networking even when the physical hardware or drivers are missing or broken. The exam wants you to keep three things distinct at a glance. A real public address, a private reserved address, and this loopback address are all different animals, and confusing them is a classic trap. So let's bring it together. Network address translation hides your internal layout and lets private addresses reach the internet, while its port-based form lets one public address serve thousands of sessions. NAT traversal reconciles it with IPsec VPNs. Static mapping opens a controlled inbound door. And the technique extends to the newer IP version too. The private ranges are reserved and unroutable. Translation is stateful because it tracks sessions, and you must never confuse self-assigned or loopback addresses with them. Read an address correctly, and you can diagnose a network at a glance. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.